If your Tkinter application contains long-running code, such as loops that might take a long time to finish, then your Tkinter application may end up freezing until your long-running code has finished. Take a look at this application. When I clicked the download button, notice how the download button stays stuck and the program no longer responds. It's because it's too busy downloading a file and it doesn't have time to refresh the window. Network-driven applications can take some time to retrieve or send data. While your application is waiting for network data to send or receive, the graphical user interface of your application may freeze. We can avoid Tkinter from freezing by using multithreading. Multithreading with Tkinter is an important topic. I'll show you how to do all this.
Hi, my name is Jobin, and I'm an open source developer. My channel is called JobinPy, and it's all about Python and Linux. Welcome to JobinPy.
So in this video, we're going to have a look at multithreading in Tkinter. Here's an example. I have a program that has a download button. It's going to simulate downloading a file. It's not going to download a file for real, but it's going to simulate downloading a file. And it's going to do that by putting the program to sleep. And then we have a test button, so when we click on it, it just prints test to the console down here. The point of this is going to check to see if our program is responsive. In other words, while we're downloading a fake test file, then we're going to check to see if we can click on test while it's downloading. If we can, then that means our program is responsive and it's multi-threaded. Okay, so here's an example. I'm going to click on download. Downloading sky.jpg. It's not a real image. It's just putting it into a delay. And it's simulating downloading the file. But notice that when I hover my mouse over test, my program is still responsive. If I click on test, I can still see test down in the console. So that means multi-threading is working. If we don't have a proper multi-threaded application, what will happen is when your program takes control of a loop that takes a long time to finish, it'll make Tkinter unresponsive. And then you won't be able to interact with your application. The users of your application will think that your program is frozen, when in fact it may not be frozen. It's just the fact that it's too busy doing something else in a different loop. Separate from Tkinter's main loop. So to get around that, we have to use multi-threading. Okay, so we're going to start by importing Tkinter. So import Tkinter as TK, and we also need TTK. From Tkinter, import TTK. Then I'm going to create a class that will be our main Tkinter window. So class main window tk.tk. And we're going to create our constructor here. And I'm going to initialize tk.tk by using super. Okay, so what we're doing here is we're inheriting from tk.tk. This is the super class. So we're using super to wake up tk.tk by running init for tk.tk. So that's why we have super here. Primarily for this. And then I'm going to set the size of the window. So self.geometry 640 by 480. Okay, and down here I'm going to say if name equal main window equal main window. And then we're going to run the main loop. Just want to make sure this works, so I'm just going to run it. Yep, so we have a blank window. So what this is doing here is it's saying that if the Python script is running by itself and not being imported, it should run these 2 lines of code. If, on the other hand, if this Python script is being imported into a different Python file, then it should not run this code. So that's what this line is doing. Okay, so next I'm going to create another method. I'm going to call it create frame buttons. And what this is going to do is going to create and return a frame that contains buttons. Okay, and here we want it to return a TTK frame. That's what it's going to return. So here I'm going to write self.frame main equal ttk.frame. It's going to go into root, so which is self, and then I'm going to create the buttons here. So self.btn download equal ttk.button, and this is going into self.frame main, and we're going to set the text to download. We're going to come back to the command of this button soon. Then we're going to have another button called btn_test. It's also going to be a TTK button. It's also going to go into frame_main. Or actually, this one here should be frame_buttons. So I'm going to rename this frame_buttons. And yeah, so it's going into frame_buttons. This one too. And we're going to set the text of this button to test. Then we're going to pack those 2 buttons. So btn download.pack self.btn test.pack. Okay, so we're basically creating a frame. In that frame, we're putting 2 buttons, and then we're packing those 2 buttons into the frame. The frame itself, it hasn't been packed anywhere yet, so we're going to return self.frame buttons. So we're going to return the frame in this method. And then from here, I'm going to call self.create frame_buttons dot, oh, I gotta call it .pack. Okay, like that. And I'm just going to run this to see what we get. Okay, so it shows up at the top. I want it to center onto the window, so I'm going to add in expand equal true, and that centers it. Okay, so under these 2 buttons, which currently don't do anything, I want to add a label, which will show us the download percentage of our download. Okay, I think I'll just add it right into this method here. So self.label status equal ttk.label. We're going to put this into frame_buttons again. So self.frame_buttons. And we're not going to change the text to anything yet, but we should pack this onto the screen. Okay, let's just run this again. Yeah, so we see our label down here, which is why there's a blank row here. That's actually our label without any text. Okay, so now we need to simulate downloading a file. How do we do that? So we have to import a module. At the top, I'm going to write from time import sleep. And I'm going to create a new method. The method is going to be called download. And it's going to ask for a file name. So the file name will just be a string. And here we're going to simulate downloading a file. So I'm going to write for progress in range 1 to 101. So this loop is going to start from 1 and it's going to stop at 101, which means it won't include 101. It's going to include 100, but it's not going to include 101. So this is simulating a percentage of 1% to 100%. Okay, and here I'm going to put sleep, number of seconds, 1. So it's going to put the program to sleep for each percentage that it loops on. Okay, so I'm going to go back to the top to my download button, and I'm going to link the click of that button to that method. So I'm going to write command equals self dot download. Okay, so just as an example, I'm going to set the file name default argument to sky.jpg. Just for now, I'm going to remove this part later. But I'm going to run this so we can see what we get. Okay, so I'm going to click on download and let's see what happens. Okay, we can see that the button is stuck. It's stuck inside. So it means right now if I try to click on test, nothing's happening. It might appear that the program is frozen, and in a way it is. What's happening is that Tkinter can't refresh the graphical user interface because it's too busy, because Python is too busy in this loop, this for loop. So what's happening is it's pausing for 1 second for each iteration. So technically after about 100 seconds, the program should free itself. And then I should be able to then interact. So after this loop is done. But we can see that this loop has caused Tkinter to not respond. And this is exactly why we need a multi-threaded application to be able to deal with this situation. Because the same kind of thing will happen when you start downloading files. So when you download a file over a network or upload a file, or any type of long wait network input and output type process, it's going to freeze up the graphical user interface. So how do we fix this? How do we prevent our program from freezing like this? So notice now that the program is back. It's functional again. That's because the 100 seconds is over. So now it's able to respond. So how do we fix this to prevent this from happening? How do I make this application responsive even when a different loop is busy doing something? So we have to do the following. And this is just one way. There's multiple ways of doing this, but this is a method that I like. First of all, I'm going to remove the default value for file name. So I'm just going to leave it as file name like that. Then we need to import a new module. So at the top, I'm going to say from threading, import thread with a capital T. So from threading, import thread. So now if I go back to my download method, actually I need a new method. So right now this download button is running self.download, but it needs to run a different method. So here I'm going to create that new method on download button clicked. So here I'm going to write new thread equal thread target equal self.download, which is our method down here. Args or arguments equal, I'm going to pass in a tuple, sky.jpg. So we're going to pretend that we're downloading sky.jpg. We're going to pretend it's a big image of the sky that it's downloading. And here I'm going to write daemon equal true. And what this does is it tells the thread module that when the main application exits, this thread should exit too. If this is false, it means that our main program can close, but the thread will still continue to run until it finishes. But we don't want that to happen. I want this thread to stop working if my user clicks on the X to close the window. So that's why I have this set to true. Okay, so what's the rest of it doing? Here, basically, we want to start a new thread. And when we start a new thread, it's not going to interrupt our Tkinter window because it's going to run in a separate thread, separate from Tkinter. Okay, so we have target equals self.download. So we're telling it which method we want it to run, which in this case, it's this one. And we're telling it which arguments to pass to this method, which is file name, which we're passing in sky.jpg for the file name. And we've already spoken about this one. We want this thread to exit when the program exits. Finally, we need to start the new thread. And here we write new thread dot start. That's it. And now this is going to start in a separate thread. So I need to go back to my download button, and I need to tell my download button to run this method instead of this method directly. So I'm going to change that. I'm going to write on download button clicked. There it is. And let's just run this to make sure it works. Okay, so I'm going to click on download and let's see what it does. Yeah, it's doing something, and I can still click on test. Well, actually test doesn't do anything currently. I haven't put in any code behind it, but we can see that it's no longer freezing after I click on download. Okay, so let's just exit the application. So far it's good. So we need to print something here so we can kind of see what's happening. So I'm going to print the progress to the console just so we can get an idea. Let's just run this again just so we can see it better. Download. So we have 1, 2, 3. So we can see that the percentages are going. And my program is still responsive. Notice if I hover my mouse over the buttons, they highlight. If I click, it goes in and it doesn't appear like it's frozen. I can resize the window. So the reason why it's responsive now is because this for loop is no longer running on the same thread as Tkinter's main loop. It's running in a separate thread altogether, so it makes it responsive. But we have another challenge, and I'll explain what that challenge is. I want to show the percentage in the main Tkinter window. In other words, if I run this again, see the percentages down here, 1%, 2%, 3%. I want those percentages to update this label, but that label is a Tkinter label. So that means my thread has to talk to Tkinter's thread, but they're in two separate threads. So how do we do that? Well, let's just try to change the label that's up here. We called it label underscore status, or self.label underscore status. So let's try doing that. So instead of printing the percentage to the console, let's try changing the label. So self.label underscore status dot configure and text equal progress. Let's make this an F string. So we'll add progress and then a percentage sign at the end, just so we can tell the user that it's a percentage. Okay, let's try this and see if it works. I'm going to click on download. 1%, 2%, 3%. Well, that seems to be working. But why? I thought it would be more difficult for a second thread to talk to the main thread. So how is my second thread, this one, or this one rather, how is this talking to the main Tkinter loop and updating the label here? I thought this wasn't supposed to work. So the issue is changing the label from a secondary thread is not reliable. Sometimes it will work and sometimes it won't. For a simple application like this, you might be okay, but there's no guarantee. So the safest way of changing Tkinter widgets from a secondary thread is to actually not do it from a secondary thread. The safest way is to change Tkinter from the main thread that the widgets came from. In other words, if I need to change this label if I need to change the text of this label, I shouldn't do it from the secondary thread, even though it currently works. It's a risky thing. So in order for me to properly change the text of this label, I have to do it in the main thread where it was originally instantiated from Tkinter's main thread. In other words, outside of this method. So how do we do that? So we have to do the following. And this is just one way, but it's a way that I like. I'm going to go back to the top, and here I'm going to import a new module. Actually, a couple of modules. From Q, import Q with a capital Q. And then from enum, import enum with a capital E, and auto with a lowercase a. Then I'm going to create a new class. I'm going to call this class ticket purpose. So it's going to be a class called ticket purpose. It's going to derive from enum and update progress text equal auto. I'm going to create a ticketing system, and this will make more sense once we go through it. But it's going to have one purpose, and you can add more purposes later as your program grows. But for this particular example, it's just going to update the progress text, which is the label in our window. And auto basically just gives this a value. You can set this to anything. You can set this to test if you really wanted to, but by setting it to auto, it automatically generates something for us, which is what this does. Then I'm going to create a class called ticket. And this won't derive from anything. It's going to be on its own. And in the constructor, I'm going to have ticket type, which will be ticket purpose up here, and then ticket value, which will in this case just be a string. Okay, so I'm going to write self dot ticket type equal ticket type, self dot ticket value equal ticket value. Okay, so this will hold the type of ticket it is, which in this case it's only one type. But if we add other types of tickets, this will hold the value for it, so we'll know. And here we're going to have the value of the ticket. And again, this will make more sense momentarily. Okay, so for now, just note that we have ticket purpose, and we have a ticket which holds the type, which is the ticket purpose essentially, and the value of the ticket. So we should go back into our download method. So that's in main window and download. This is our secondary thread essentially, because if you remember here, we're instantiating a thread object, and which is now going to run self.download in a new thread, which is what this will run in. So here I'm going to write download in a separate thread. So this is what this method is doing. But I'm going to do something different here. Instead of modifying the label directly, I'm going to do the following. I'm going to create a ticket instance. So ticket equal ticket, and the ticket type will be ticket purpose dot update progress text, and the ticket value will be the string that we want to show in our label, which in this case will be an F string, downloading file name, and then the percentage. Or actually the percentage will come from progress, so progress percentage. And I'll just put some dots here. So downloading file name, which is from here, and the progress, which is from the for loop. And then we have a percentage sign. So this will be a ticket that we will eventually pass to the main thread, and the main thread will read this ticket and it'll do what it needs to do. Okay, so we've created our ticket. What do we do with it now? We need to queue it up in a queue. So let's do that. Remember how at the top we imported queue? Now we get to use it. So first I have to actually instantiate it. So I'm going to go to the constructor of our main window, so our main Tkinter window, and I'm going to create a variable called self.queue_message equal queue, like that. So this will be our queue. Okay, so now that we have this variable, I'm going to go back into our download method, which runs in a separate thread, and I'm going to add this ticket to the queue. So how do we do that? Well, we just created our queue variable, so self.queueMessage.put. And what are we putting? We're putting the ticket into the queue. So I'm just going to pass in the ticket like that. And you can think of the queue as a list. It's kind of like a list. So each time you run the put method, it just adds something to the queue. It adds an item to the queue. So for every iteration of this progress from 1 to 100, it's going to add a separate item to the queue each time. But the queue is thread safe. So this type of queue is safe to use in a multi-threaded environment. So that's why we're using this. So we've added the ticket to the queue. What do we do with it now? Well, now we need to notify our main thread, the thread that Tkinter is from, that this queue exists, that this ticket exists. So to notify Tkinter to check the main thread, we have to put in self.event_generate. So what is self? Self is essentially root, like our root window. Because remember, our main window came from tk.tk. So tk.tk is basically your root window. Okay, so self.event_generate. And what are we going to generate? Well, I'm going to create a virtual event, which will just be an event that I'm going to create. I'm going to put double angled brackets like that, and I'm going to put in check queue. So check queue doesn't mean anything in Tkinter. It's a name that I just came up with. I can call this anything. I can call this the sky is blue, and it would still work. But I'm just going to call it check queue because it makes sense to me. And because there are double angled brackets like this, it's a virtual event, which means it's something that's user defined by the programmer. So in this case, I've defined this. So we need to bind this to something. In other words, whenever we run event generate and then our defined virtual event, we need it to run a method. Now we're in our separate thread here, this download method that runs in a separate thread. I'm going to go back to our main constructor, our main window constructor. And here I'm going to put self.bind, and we're binding check queue, which is what we just came up with. And we want to bind this to self.check_queue. So whenever we run event generate check queue, now it's going to run this method for us automatically, but we need to create this method. So let's create it now. So here I'm going to put check queue self, and it's going to pass in an event automatically. And for a description, I'm going to put read the queue. Okay, so we're going to get the queue. So I'm going to call this message. I'm going to give it a type hint of ticket so that my IDE that I'm using knows that message will be associated with a ticket object. So when I type in MSG dot, it can give me some tips, ticket type, ticket value. So this is a type hint. Then I'm going to put message equal self.queue message dot get. So remember how we put the ticket in the queue by using the put method in our second thread? Well, here we're getting the message. And when we get the message, it automatically removes it from the queue, similar to the pop method in a list. So now this message will contain the ticket. And this check queue is not in the second thread. It's going to be in the main thread. So now we can read what the ticket says and we can act accordingly. Okay, so what type of ticket is it? We're going to write if message dot ticket type equal ticket purpose dot update progress text. If it's that type of ticket, well, we know what to do. If it's that type of ticket, we want to update our label. So here I'm going to put self.lbl status.configure text equal message.ticket value. And if you had other purposes from a secondary thread, you would add it to another if statement. But here we only have one purpose that a ticket is used for, and it's for updating the status label. So that's what we're doing here. Okay, so let's recap on what we're doing here. So in our download method, we're putting that ticket that we created here, the ticket that gets created for every iteration of the progress. We're putting that ticket into our queue. And what does that ticket have? Well, it just has text, which contains the progress. And the ticket type is ticket purpose dot update progress text. So we're putting that ticket into the queue, and on the next line, we're going to tell Tkinter to check the queue by running a method that we've defined. So event generate will cause Tkinter to check the binding for what we've defined here, and it'll run the method that we've specified in the main thread, not from the second thread. It's important to note that by default, event generate will run the virtual event that you specify immediately. However, you could tell Tkinter when to run the virtual event. For example, you could use self.event_generate, check queue, and then we can pass when equal tail. Here, tail means to queue the event behind any existing events. But why would you want to do that? Well, sometimes you may not want to run a virtual event right away. For example, when you need to make a change to a top-level window, but the top-level window hasn't finished loading yet. I'll leave a description in the comments for other possible values that you can use with event generate. Here, we're telling Tkinter to run this method, which is now in the main thread. And from here, we can get the queue, which is the ticket. And the ticket gets removed from the queue automatically when we run the get method. And from here, we're actually reading the ticket now. If the ticket type is update progress text, then change the text of that label to whatever that our second thread wants us to set it to. But now this is running in the main thread, so it's safe. Okay, so let's just see if things are working. I'm just going to run this program. Going to click on download. Yeah, it's working. So we're actually updating the label from the main thread and not from the secondary thread. So this is a more reliable way of keeping your program active, and we can still hover the mouse over the buttons and they respond. Maybe we should put some code in the test button here. So when we click on it, we can cause it to do something. So going back to our init constructor, actually it's inside this method, create frame underscore buttons. So button test, here it is. So from here, I'm going to put in command equals self.on test button clicked. This is for the test button. And on test button clicked. And we're just going to print test to the console. Okay, I'm going to click on test. It works here. And if I click on download, I can click on test again, and it still works again and again. And our program is still responsive. So how do we know that our download has fully finished? How do we change the text to show that the download is finished? Okay, so let's go back into our method that runs in a secondary thread, which is this one. So we know that after this for loop is finished, it means that our fake download has finished. Okay, so we're going to create another ticket to tell our main thread that the download has finished. So here I'm going to put ticket equal ticket type equal ticket purpose dot update progress text. So the same as before. And the ticket value, I'm going to set it to finished downloading, like that. And then from here, I'm going to add this to the queue. I'm going to add this ticket to the queue. And I'm going to call event generate, so the main thread will read the queue. Check queue, like that. Okay, so let's try that and see if it works. I'm going to click on download. And I'm just going to pause here and then get to near the end, and I'll unpause it again. Okay, so here we are. The download is almost finished. And let's see if it shows our text. It does. It says finish downloading. So this is from the last ticket that we sent to the queue. We've basically covered how to make Tkinter calls from a secondary thread, and we learned how to use multi-threading with Tkinter. All other graphical user interface toolkits I've used in the past have similar issues with freezing the interface while the application is busy. It's not limited to just Tkinter. This is the nature of graphical user interface toolkits. Tkinter is constantly running its main loop, and it needs the main loop to run uninterrupted so that your application remains responsive. I hope this was useful to you. Until the next tutorial, thanks for watching.